A submarine fiber optic cable plant has been opened in Russia, which, together with other enterprises, will provide the country with the ability to lay sovereign communication lines along the seabed. Right now, we are already building 3 giant trunk lines in the Arctic, which very few people know about. Why are they needed? How are they connected to defense capability? And why can we be proud of such projects without any doubt? We'll talk about this and about the new hero of the week after a brief summary of positive news. At Sevmash, the keel was laid for the nuclear submarine Murmansk of the Yasen M project. Rostselmash has launched serial production of the most powerful forage harvester, the RSM F2750, in Kaluga. Production of the new 5-seat version of the Tenet T8 crossover has started. In Khabarovsk, the Rhino 25 dredger has been launched, and in Moscow, production of medical equipment and airfield lighting equipment has begun. In the Moscow region, a pharmaceutical production facility has been opened. In Primorsky Krai, an industrial gas production facility. In the Urals, a metal rolling plant. In Ivanovo region, an industrial steam boiler plant. In Leningrad region, a mounting foam production facility. And in Dagestan, a rice processing plant. In Primorsky Krai, an underwater fiber optic cable plant has been opened with investments exceeding 1 billion rubles. Such a cable can contain up to 96 optical fibers, and thanks to its special armored design, can operate at depths of up to 4 kilometers for decades. But most importantly, this is a Russian product. The optical core, the heart of the future cable, is produced at a plant in Perm. Then the semi-finished product is sent to a new facility in Primary, where the finished product is assembled and immediately loaded onto the cable-laying ship. After the Enterprise reaches full capacity, it will produce 2,500 kilometers of cable per year, and the location in the Far East was chosen for a reason. It is here that both existing lines such as Sakhalin, Magadan, Kamchatka, Chukotka, and Sakhalin Kuril Islands originate. The same goes for those under construction, and now let's talk about them in more detail. Submarine cables have long become an important part of the global economy. They carry 95% of international internet traffic. Although digitalization allows data to be sold as a commodity and not just as a noble purchase by data teams, without cables connecting them into one global network, none of this would work. Unlike satellite communication, cable is more reliable, costs less, and is less susceptible to interference. Compared to satellite communication, cable connections are more reliable and less expensive to operate. It is faster and better protected from interference and interception, which is why it is considered part of critical infrastructure. During the recent conflict in the Middle East, Iran not only delivered several painful blows to Arab states, but also warned that it could disable the internet cables laid along the bottom of the Strait of Hormuz. At the same time, Iran itself would only be partially affected, since most of its traffic comes through land routes via Turkey, Armenia, and Azerbaijan. But its neighbors on the southern coast would suffer significant losses, since 90% of their traffic relies on the sea routes passing through the strait. However, even without the destruction of the cables, the war against Iran has led to a dangerous situation. Communication lines have not been serviced for months because there was reluctance to send specialized vessels out to sea, and insurers are unwilling to cover possible losses. Basically, the whole world is connected by undersea cables, and everything, AI, neural networks, cryptocurrencies, and other trendy tools, so to speak, depends on fiber optic cables as thin as a human hair. But in Russia, the situation is different. Russia is the largest country on the planet. Mainland trunk lines connect our cities into a single network, and underwater cables link Kaliningrad in the west and the islands in the east. But there were two gaps in this scheme. The first was the long-standing dependence on foreign suppliers. We purchased the cable itself, the raw materials for its production, and the network equipment. In recent years, Russia has established domestic production to replace those imports, and another plant in Primory is proof of that. However, the second problem is that a significant part of our Arctic territories was not connected to cable trunk lines and depended on satellite internet, which slowed down the development of northern cities and settlements. Therefore, it was decided to build 3 new megalines at once. The first one, Polar Express, is the most impressive. The underwater cable, stretching 12,650 kilometers, runs along the northern coast of Russia from Murmansk to Vladivostok. It has landing points in 9 settlements and a high capacity. The line is already being laid, and this year it reached Dixon. Next, it will extend toward the Yakut settlement of Tixi. The second project is called Northern Lights. It can be considered as a backup. The company implementing it, Supertel, has created a highly efficient Russian underwater optical amplifier and is now finishing the development of its modified version with double the capacity. And finally, the third project is called Arctic Synergy. It is land-based, but necessary to connect the subsea lines to cities and settlements on land. Its implementation began this year. A network 7,000 kilometers long will be built, passing through 60 meters and 151 settlements. This is the work our country is doing now, and this is why we need so much of our own fiber optic cable and equipment. Now think about the fact that all this is happening not in the warm southern seas, but in the harshest Arctic conditions. Just surveying the underwater route for 12,000 kilometers is already a national project. And in some places, the line also needs to be buried in the seabed to avoid breaks. And the requirements for equipment to work in such conditions are extremely high. Russia is doing all this on its own, but is it really just to provide internet access to, let's be honest, not very populous northern settlements? In the Russian Arctic, there are a huge number of military bases, garrisons, island and coastal facilities, radar stations, supply bases, as well as the Northern Fleet. All of them need modern and secure communications. Underwater lines will not only connect them into a single network, but also create a unified control system with the Pacific Fleet. And that means we will be able to respond more quickly to changes in the situation in areas that are strategically important to us, and not be afraid of enemy attempts to jam or distort the signal. This is how the opening of just one important fiber optic plant in Primory in the north is actually part of a large and well thought out national strategy. And that's not all, because just recently another important piece of news on this topic became known. Rosatom Enterprises, NIINPO Lush, and Giryad Medi have, for the first time in Russian history, established the production of ultra-pure red phosphorus and phosphorus oxyfluoride. These substances are critically important for electronics production and were previously purchased from other countries. The implementation of the project took about 2.5 years. The production process itself is extremely high-tech and is available to only a handful of countries in the world. It doesn't require a facility or a huge chemical plant, but it does require fundamental knowledge, unique sterile conditions, and a high level of automation, since phosphorus compounds are harmful to humans. Especially pure phosphorus oxyfluoride is required, among other things, for the production of fiber optic cables. It makes it possible to create fiber optic cables with precisely defined optical characteristics, low losses, and high mechanical reliability, which is especially important for use in underwater communication lines, which we have talked about. Now, Russia has achieved independence in this area, literally at the atomic level. This is what real comprehensive import substitution means, something to be proud of. We congratulate all the participants of the project on their victory and wish them new achievements. Next, the announcement and the story of the heroes.